So when you're dividing, it's the same thing. You're going to use the same exponent rules you've always used. You just have to pay attention to the type of problem that you have. So like if we look at number 15, I still think that I'm going to distribute that 5 in there and make this 56 to the 5/4 power over 7 to the 5/4 power. Now at this point we can't have exponents that are fractions, so what I'm going to do, because this exponent is exactly the same, we can write this under the same radical because the denominator is the same, so it's going to have the same index, and then we can raise it to the same power. So what I'm going to do is say, okay, keep the 56 over 7, but make it the 4th root of 56 over 7 to the 5th power. You guys know that 56 over 7, or 56 divided by 7, is 8, and to the 5th power. So there are no perfect 4th roots. In 8, you can really only factor it to 2 times 2 times 2. So we can leave it there. No negative exponents, no fraction exponents, no radicals in the denominator. So you're good to go. And the other weird thing with these guys is that if you didn't start this problem the same way as I did, you will get to the same answer because there's multiple ways that you guys can do these problems and get to the same end result. It's kind of what makes them nice, but also makes them confusing at the same time. So for number 16, if you guys have a division problem, you want to subtract the exponents. If you guys had x to the 5th over x to the 3rd, you'd subtract and get x squared. Same idea here. Now this would technically be 10 to the 1st, but if we're trying to subtract it with 2/5, we want to write the equivalent value of 1 in terms of fifths, which is 5/5. So 5/5 minus 2/5 gives us 3/5. But you can't have an exponent that's fraction, so all we do is rewrite it as the 5th root of 10 cubed. So sort of like moving negative exponents makes them positive, fixes your problem. Here, you can fix your exponents that are fraction problem by rewriting it in radical form. So before we do 17, let's scoot down here and do 18 and 19. Don't mind my animals. So this is where the property of combining two radicals into the same is going to help us. Because we can't have radicals in the denominator, but if we rewrite this as one radical and see if we can simplify it first, that might get rid of that problem for us. So if we put in one radical and we get 80 over 5, 80 divided by 5 is 16. So we end up with not the 4th root of a fraction, but the 4th root of 16. And if you guys check your power sheet, or if you break 16 down, you'll find that it's a perfect 4th root, and the 4th root of 16 is just 2. So just like that, by combining it into one big radical with that fraction underneath of it, we found it to be a perfect 4th root, and we didn't have to worry about rationalizing anything, and we no longer have a radical in the denominator. So let's look at number 19. Now remember, when you don't see the index, it's an index of 2. So we just have variables here, so there's no numbers to take the square root of. So we're checking to see how many times does 2 go into 6 and 2 go into 18? And we need to see if there's anything left to be still underneath that radical. So in this case, it actually works out pretty nicely because 6 is divisible by 2 and 18 is divisible by 2. So what happens is we're just left with r to the 6 halves and s to the 18 halves. So we're left with r cubed over s to the 9th. No negative exponents, no exponents that are fractions. So the last one we're going to look at is that one we skipped, number 17. Looks a little crazy, but it's not too bad. So we've got A, B's, and C's. So the first thing I'm going to do is divide those coefficients out in the front because I can, and it is a division problem. That's what a fraction is. So you do the operation, remember, with the coefficients or the numbers. So 56 divided by 7 is just 8. And if A has an exponent that's in 6, this is A to the first, remember, so I'm just going to make that to be A to the 6th 6. So 6 minus 5 gives us A to the 1/6 power. B to the 1/4 is just going to stay B for right now. And this C to the -3rd actually has to get moved up here to the top with everything else, so that actually works out nicely. So you could put this over 1 if you wanted to, but not necessary. So now the good thing is we don't have any negative exponents left, but we need to fix these terms with the fraction exponents. So 8c cubed will stay. And instead of trying to find a common denominator, I'm okay with keeping it as just the 6th root of A, or A to the 1st, it doesn't matter if you put that power of 1, times the 4th root of B. If you would have made them like denominators and made them both have a denominator of 12, you could have put them under the same radical, but that's okay. We can leave it as 8c cubed times the 6th root of A times the 4th root of B.